Hi, I'm Desiree. This is our module for Excel exam. These are the formulas for each problem. Problem number 1 is about a Gallup poll in the top 3 countries that citizens love from all over the world. In this Gallup scenario, with several surveys done, there were many people within different countries wanting to move. The top 3 countries people adore are the US, Canada, and the UK. Overall, there are 29% of people who actually want to stay and who say they are happy where they are. 71%, however, indeed want to leave. 240,000, which is 34% of a million, want to move to the US. 70,000, which is 10% of a million, want to move to both the UK and Canada. We can only see 34% of 71% out of a million, which needs to be calculated first. Over here, it just shows the percentage of people that want to stay and move. It shows the percentage here of what I just read, about 34% wanting to go to the United States, which is about 240,000, 10% to Canada and the UK, which are 70,000 people. Shows that over here in the bar graph as well, and the pie chart. Number 2 is the Spanish horse carriage ride. This is an explanation of a carriage ride in Spain. On the left-hand table, one can see that it's $2 to climb into the carriage right off the bat. After the initial mile, one will pay $2.75 a mile. This cost includes both the initial $2 to climb aboard and 75 cents for each mile thereafter. One will see at 0 miles on the black graph that the cost is $2. This is where the x-axis and the y-axis meet for the first time. One can also understand that there's no negative values here since we travel only forward. The climb in dollars to distance starts to decrease because the cost is less than 1 unit. One can see when the carriage travels 5 miles, the cost is almost $6. And when it travels 10 miles, the cost is $9.50. And these are over here on this table and also on this black graph. You can see them pretty easy. When one reaches 12 miles on the graph, it's easy to see by the yellow arrow over here. The cost is $11. That's just one example. Number 3 is an Adidas company, what they put in their profit. There is a table and graph of the Adidas company. The table conveys what the company first puts in to start and their profit according to sales. The input shows an initial investment of $240 to begin the enterprise. Adidas did seemingly well. They initially invested about $300. This was only down 60 from their initial investment. Soon after, Adidas hit rock bottom. They started gaining, and after selling only about 13 pairs of shoes, they broke even with just about $20, since they could not sell fractions of shoes. When Adidas sold about 19 pairs of shoes, and I say about 19 because, again, we can't sell pieces of shoe, they made a profit of $500. It seems Adidas will continue to profit if they keep on the same path and lead to millionaire status. Number 4 is the major leagues. Over here is the formula. This is the table, the graph. This is a scenario within the major leagues. In this story, a baseball pitcher who is 6 feet tall throws a ball straight up in the air. At only about 1 second, the ball has already reached 122 feet, according to the table and graph. At 4 seconds, the ball has reached about 275 feet. The ball quickly reaches the ground at 9 seconds after being thrown hundreds of feet in the air. You can see here at 4 seconds, if you look at the star here, it's already over 250 feet. Number 5, this is the crazy math professor in Costa Rica. Graph 1 shows a linear graph on the right side. Option 1 of the table correlates to the table, shows how many days one can stay at this resort in Costa Rica. First payment option is $200 per day per person, which decreases at a rate of $25 per night. This scenario zeroes out at day 9. Second option in the table, which also has the corresponding quadrant graph, is $300 flat fee for the first day, and each day after, only pays 10 times the square number of days one has been there from the previous day's cost. This option zeroes out at day 5. Option 3, exponential decline, is $500 the first day, $250 the next day, then only half daily as much as the previous day. In any case, one must leave when the cost reaches 0. As you can see, each option varies in price by day. The exponential line on graph 3 never actually touches the ground, though it looks deceiving. So the same table just depends on how many times one can continue to split the fractions as to what the price may be. Number 6 is fossil years in 1964. In this scenario, someone found fossilized dental remains in England in the mid-60s. They belong to a human being. This means that humans were in that area longer than previously theoried. The carbon formula on the left, over here, shows the input and output of function notation. 37% of carbon-14 remained is found to be somewhere around 45,000 years prior. It's almost exact at 459. Also, one can easily view the table and graph and see what's going on here. For instance, at the top, 0 years shows 100% remaining carbon. On the graph, one can see this on the far left line as well. Thank you.